Smokeless Chimney S1 bellows controller live fire testing video. Hello, my name is Noel. I am the president and founder of Smokeless Chimney, and I am your narrator for the video today. This is live fire testing. What I'm testing is the controller that's on the floor to the right, and I have coded a certain fan profile that I want to test today. Information on the wood stove. It is an S244. It is a Century Heating. Here are the specs. It is recommended for a 500 to 1,000 square foot. Heating capacity in BTU per hour per EPA test wood is 26,100. And heating capacity in BTUs per hour for seasoned cordwood is 40,000 BTU per hour. Optimum efficiency is 82%. The stove is 174 pounds or 79 kilograms, a firebox of 1.3 cubic feet. The door size is 15 inches wide by 7.75 inches high. And let's see, what else do we have here? It's got a 6-inch diameter duct. Now, the chimney in this configuration goes 4 feet vertical and then 12 feet horizontal. So it is a horizontal chimney. This is not recommended by the manufacturer, but is necessary for my test. For the test today, I'm putting in blocks of maple hardwood, 4 pounds of maple hardwood. And this is a single batch test. In other words, I load up the wood and let the program controller fan do what it's going to do. And I don't add any wood during this test series. So all of the data that you see in the test today is a single batch. So I'm setting up the data acquisition system that is up and to the right, and now I am power cycling the controller. And this is to say I want to start from here. So the program on the controller is currently designed that it starts from 0. I use a propane torch to light my fires. Here is some of the code, the main code that I'm working with today. Most people won't be able to read it, but it is a C++ code to program an Arduino Uno. And it's controlling that fan, and it also reads the temperature of the shell of the wood stove. So based on the temperature of the shell of the wood stove, it goes through some decision processes and decides what the fan should be spinning at. So if you can read that, great. If you can't, you don't need to worry about that. I always want the fan to be adjusting or constantly changing its spin rate. And there's a reason for that, and I may be able to get into that later in the video. Also, I have spun the video up to 10 times in normal speed. It is a 2-hour test, and this is a 16-minute video, so I know it wouldn't fit within the 16 minutes. So I sped it up for the most part to condense it. There will be overlays of charts with the backdrop of the fire in the background. The time is correct. A wood stove will smoke the most when it's cold or at a cold startup. And the idea is that you warm up or heat up your wood stove as quickly as possible to reduce the amount of smoke that it puts out. The fan program is designed to heat the wood stove up as quickly as possible. Here is a chart of one of the test series today, and it has a Tmax of 400. You can see we have a rate of rise, a peak, and a tail of the fire. So this is in real time, and we are at 20 minutes into the fire, and the fire should be getting nice and warm at this time. I want the fan to be constantly changing its flow through the wood stove so that the flamelets will incorporate or impinge on new material all the time. If you provide a constant flow of air, the flamelet hits or impinges on material that chars over, and you get a reduced flame rate, flame growth or heat release rate. So the idea I have is you constantly vary or adjust the flow rate of the fan up and down, and the flamelets incorporate new material. Now, you always have to be giving it enough air. If you don't give it enough air at this phase, you're going to generate more smoke. So the trick is, are we giving it enough air? The way to determine whether we're giving enough air is to look at the rate of rise chart. This chart indicates the temperature rise per minute, and in some it looks like it's around 4 degrees per minute below 40 minutes, and then close to 50 minutes it goes up to 14 as a maximum, 14 degrees per minute. This is a rather large rapid rise. This is a fairly small wood stove, so I think it's okay. This rate of rise is really where the science is. If we can get that rate of rise steep and controlled, we will produce less smoke on startup on our wood stoves. And so that is most of my research is in this rate of rise area. Once the wood stove is up to operating temperature, we don't have much smoke being generated. So less work is being done in those areas. We are now in the beginning of the peak heat release rate of the wood stove. This is answering the question, are we putting enough air into the wood stove? Are we putting the right amount of air into the wood stove? And are we putting it in a way that supports the fire growth and reducing smoke? I think we are, and I think visually you can see that here. Keep in mind, the chimney on this wood stove is horizontal. It does not get any natural draft or much of any natural draft. The fan creates some momentum in the system, and you can shut the fan off for short periods of time, but you are highly dependent on the fan for this fire. The chart on the left, I put in a dark oval on the area where the wood stove chart is going to smoke the most. So we're trying to get through that zone as quickly as possible. the chart on the right is the whole chart. So you see a rate of rise or a rising section, and then the falling section, which we call the tail. The peak is the peak. So the material in the wood stove is charred over. It's at operating temperature now. It's right near 400 degrees Fahrenheit, measured on the shell of the wood stove. Manufacturer has a maximum temperature of 475. So I've got the controller that will shut off air when it reaches somewhere around 425. I'm adjusting that. I adjusted that during the week, so I don't recall on this test what it was set at, but I'm watching the peak temperature to see that it doesn't go too high. If you see the fan stop momentarily, that is because the controller has said that the wood stove is too hot. We want to get through this gray circle as quickly as possible. So we're going to push the wood stove flaming process through this. The video is speeded up here, but I do like the flaming on this wood stove. This is real time, and the wood stove provides most of its air from the top, and I think it makes a nice flame. So we are at peak temperature here, and we're slowing down the airflow through the wood stove. We have nice, lazy, calming flames. These are the types of flames I like when I'm relaxing near my wood stove. Using the charts we've created, I have this triangle, which has one face as the rate of rise, one face as the tail, and anything over 100 degrees Fahrenheit, I say, is heating the room. So this is the heating area triangle. Here we can see the whole curve, the rate of rise, the peak, and the tail. We want to stretch that tail, and so that's the next phase of this video, is stretching the tail. So we reduce the airflow into the wood stove to stretch the tail. Once we're over the peak, somewhere around 1/2 hour after the peak, the wood stove isn't going to smoke. It's all glowing embers, and we don't want to put too much air into the wood stove. We just want to keep the embers burning. So this triangle is what we call the refueling triangle. You can refuel, you can put new wood in this wood stove with anywhere in that triangle, and it won't smoke much. If you wait until the stove cools off, below, let's say 200, maybe 250 on some stoves, it's going to take time. You're going to have to add flame to that. To the fuel to make it not smoke. This is the peak. The peak is controlled by the electronic controller and fan, and is definitely a transition between the rising section of the curve and the tail section of the curve. And the peak may only be 30 minutes above 400 degrees Fahrenheit. However, it's a transition point in your wood stove fuel curve. Right after the peak, or 30 minutes after the peak, is probably a good time to refuel your wood stove. Let's talk about the tail. The tail, we want to stretch the tail because A, the tail doesn't smoke. There's not a lot of particulate matter going out the wood stove. I don't see anything. We can reduce the airflow to a bare minimum because we don't want to cool the wood stove off from the inside. And we want to decide at this point, are we going to refuel or are we just going to let the fire go out? Here are some charts. We're familiar with the chart on the upper left. This is 8 pounds of wood done later in the week. Our rate of rise curve is on the upper right. Our fan curve, or the amount of power we're putting into the fan, is in the lower left. And you can see that near the peak, it's throttling the airflow back. And at the tail, it's reducing the airflow just to keep it spinning. Smokeless Chimney, www.smokelesschimney.com. Warm homes and clean air for everyone. Thanks for watching.